All right, class, this is an answer video for the balancing equations and reaction types homework. It was originally due today, but I want to give you some extra time to lock this stuff in after our practice quiz and go through this so you actually have the answers. So you can literally copy these answers by hand, that's okay, but please watch this video and it's quite useful. So if we look at this first one here, we've got Na plus O2, and that's oxygen. That's a diatomic molecule, okay? Diatomic element. Whoops. Now I'm going to kind of speed run this as fast as I can. So we look at sodium, and sodium is by itself. That's an element. And it's reacting with oxygen, O2. Now, you can show these products or substances with or without the charges. It actually doesn't matter. If we have the chemical formulas correct, we're all good to go, which we have all the chemical formulas correct given by the textbook. All right, but I am going to add in. So you got two sodiums. I'm going to add in this level of detail and an oxide because it's just good learning. Okay. All right, so let's just divide these two there. And I can simply do a bit of cloning and just visually inspect and say, you know what? I've got one silver circle on the left side, that atom of sodium, and I've got two sodium ions built into the formula unit of sodium oxide. So we can go like this. We can go sodium. Now, you didn't have to do the word equation, but it's good practice to do that. Because now we see that there's two elements reacting to form one product, one compound product called sodium oxide. Okay, and sorry for the background noise. I don't have my AirPods with me today, but that's okay. This should be sufficient. All right, if I need another red circle on this side, well, that means that I've got to build an entire same formula unit because Na2O. And now I've got four silver circles, so we're going to draw four atoms of sodium on the left side. So what we can say here is that four atoms of sodium react with one molecule of oxygen to form 2 units of sodium oxide. Now, when we talk about reaction types, this thing follows this pattern. A plus B is AB. And according to your textbook on page 145, and I'm going to read this right out, okay? 2 or more reactants combine to produce a new product. So that's called a synthesis. And since it's plus oxygen, also a combustion. Because a combustion is anything plus oxygen. Okay, so that one's done. Oh, I want to show you the accounting method that would have gone with this, all right, if you like doing it that way. So we'd go Na and O on that side, and Na and O on that side, and we say, well, we got 2 there, 1 there, 2 there, 1 there. Okay, so again, if I want to go times 2, then I got to go that, but times 2, so that would equal 2, and that would equal 4, and then I go that times 4 equals 4. Now I got to put my balanced coefficients up in front. 4 sodium atoms react with 1 oxygen molecule to produce 2 units of sodium oxide, and now we're totally balanced, and we've identified the type of reaction. Let's go to the next one. Okay. SnO2 plus H2 gives us water and tin. Again, I didn't expect you to have the word equation, but I can do that with you. Okay, so this is called tin 4 oxide. I wouldn't expect you to know how to do that one. And there's another one of those diatomics. Okay, and so now we can go, well, this is just like kind of like AB plus C, and that's going to boot out the A plus CB. Okay, or we can go compound plus element, and gives us a new element. A new compound. So we've got somebody single showing up to the dance, meeting a couple, and you got yourself a new couple or compound and a new single, 10. And we remember that if this happens spontaneously, it's actually in the favor. Okay, now I'll just draw this one. We're going to do it like this. No charges shown. Really easy, like poker chips. Okay, so from now on, I won't even do the poker chips. That's fine. We don't have to. The charges are for, doing the onyx. Okay, now check this out. Okay, let's make some gray for hydrogen there. Okay. So you've got a unit. Now, if you want to put the charges in, you can. Okay, so we know, for example, let me just get a white, because then I can draw in. We know each of these oxides is a 2 minus. You can put these in. You don't have to, though. Watch this. Okay, so then that one's a +4 or 4+, whatever. Okay, and matter can't be created or destroyed. It can only change form. So according to the skeleton formula, I've got that there, a silver circle there, and I've got a water molecule, H2O. Well, we know water. That's easy enough. There we go. 1 and 2. Okay, clearly we've got one red circle, so if I want to clone that red circle, well, then some hydrogens have to come with it. There you go. And now I look and I say, well, I've got 2 silver circles, or 1 silver circle, a 10 on the left side, a 10 on the right side. I've got 2 red circles, and then I've got my hydrogen molecule, so I need another one of those here. Okay. So here comes the balancing. I'll use a fancy, cool color pen for that, okay? So 2 molecules of hydrogen are going to give us 2 molecules of water. So we could say 1 formula unit of tin 4 oxide reacts with 2 molecules of hydrogen to form tin and water. And we know then this is single displacement. Now, I know there's not 2 metals, so hydrogen often acts like a metal, and that's why it's on the left side of the periodic table. All right, one element takes the place of another element in a compound. That's the definition on page 145. And these definitions on page 145 are really good to have. Let's put it that way, if you can catch my hint. All right, let's do C. So we got SeCl6 plus O2. SeO2 plus Cl2. Okay. Now, I'm not even going to bother with anything here in terms of charges and all that. We can just, I'm going to go full on straight up poker chip here. Okay. Selenium is actually technically a non-metal. All right. That's fine. All right. So I'm going to need a cool color for selenium. We'll do this teal. That's kind of neat. Okay. And chloride is usually done in green. No, we need a red for oxygen. And let's do green. Okay. 6. How do I want to lay these guys out? Well, you can just go straight across. That's cool. Right? You don't have to do anything fancy. All right, so there's that. And then 6 chlorides, I should say. There we go. Okay. And now we're going to draw our O2 molecule there. And that's the left side, and then the right side's over here. A good hint is to always balance everything first and save oxygen and hydrogen to the end, because there's usually a water molecule you can play with. All right. Now Cl2 is that diatomic chlorine, and so we can't change that, but it's pretty clear that we're going to need at least 3 of these to start off. Okay, because 2 times 3 is 6, and lo and behold, look at that. All right, so now we see something cool going on here. We see a reaction, something plus O2. And from that, we know that that kind of reaction is a combustion. Anything plus O2 is a combustion. Not anything making O2 is combustion, because we had someone ask about that, and it was really cool. I just said, well, that would mean that if we lit a fire with a campfire, combustion, that would actually make oxygen. Well, that's not how it works. It uses up oxygen. So here, we're using up oxygen. Now, what's happened then is if I look at my general formulas or definitions, one element takes the place of another in a compound. So the oxides took the place of the chlorides. So this is actually a single displacement as well, even though no metals were involved. There you go. There's your general formula. Okay. Now we can do the. I just like the cloning method. That's just my method of choice. And it's really actually somewhat the same as a counting method, which is fine too, okay? How you do it, as long as you show your work, how you got it, that's what I'm after, okay? I just want you to show your work. I want you to be able to justify why you got what you got. Okay, next one is Fe plus O2. All right, now somebody today was asking me about rust. What is rust? Well, rust is when iron oxidizes. Now, the main component of rust is this chemical, but there are others like iron hydroxide, iron 3 hydroxide is another of them. Okay, that's fine. So this is rust. There's your iron there. And watch this. I'm not even going to do charges. We don't have to get that fancy for balancing. We can literally do that poker chip method. And we don't have to draw them out in any fancy format. We'll just draw them side by side like that. And then it can become really apparent and easy. And I go, well, wait a minute there. Okay, I got 2 Fe's, so let's just double those guys up right there. Okay, but that doesn't look right. I need some more oxygens. And the lowest common number between 2 and 3 is 6 like that. You see? So that means I need another unit of iron oxide, iron 3 oxide it's actually called, like that. So now I can say 2, I think we're good. Yeah, there we are. So we got 2, uh-oh, not done balancing. See how quickly that happens when you rush. You just want it over with, because it's Friday or Thursday, but before a long weekend for you guys. All right, so I got 4 atoms of iron reacting with 3 molecules of oxygen to make 2 units of iron 3 oxide. All right. Now, I will put the charges in after so that you can see how it all kind of works out, which is kind of cool. But you don't have to use the charges for balancing. That's the cool part. We can take that level of detail off. Okay, so 4 of these guys react with 3 of these guys to produce 2 of those guys. Okay, so 4 atoms of iron react with 3 molecules of oxygen to make 2 units of iron 3 oxide. Now watch this. I said the charges, everything will work out. Okay, so 3 plus, 3 plus, 3 plus, 3 plus. So that's a total of 6. Check it out. Every oxide is a 2 minus, a 2 minus, 2 minus here. So that zeroes out. A formula unit is a total charge of 0. And there we go. But we didn't even need to do that. Okay. Now obviously we have one product. A plus B gives us AB. Synthesis. Whoa. Synthesis. Synthesis. Sync up. Synthesis means to join, to build, to assemble. We've assembled one product, but it's also A plus O2. AO. Now, like whatever these numbers are, it doesn't matter. It's now a compound, an oxide compound. Okay, so this is also a combustion. It's both. Okay, there's that one done. Okay, let's move on to our last one. Okay, Cu. Now, sulfur is a neat element. there actually is an octa-atomic version of sulfur in its elemental form. It's kind of weird. I don't even know what the heck that looks like. But what I do know is the pure sulfur is bright yellow. If you ever go to British Columbia in Vancouver, there's they obviously have a sulfur mine somewhere, and there's this huge mountain of sulfur at some plant near the coast, and they're obviously selling it. Okay, so U2S. All right. So now I can just go ahead and use my cool little color pens here. Well, there's a copper there. And again, I'm not even going to bother with charges. Okay, we'll just draw the circles as we go. Okay, according to their formula. Oh boy. Okay, so that's this one here. And now I got to draw 8 yellows. Okay, 1, 2, 3, 4, 5, 6, 7, and 8. And I'll just color those guys in. So however this, and that's actually like how it, how we have O2, well, we have S8. That's actually a form. And then this clump would sort of somehow connect up with others to make pure sulfur, which is kind of weird. But that's what it is. That's how nature works. It doesn't always follow our rules. But when they react together, what we're seeing here then is that 2 coppers are going to join up to 1 sulfur. Oh boy, this is going to be a lot of drawing, isn't it? Because if that's 8, we're starting off, then we have to draw 8 here. That's okay. I'm just doodling, man. No big deal. You can doodle. This is why I want you to have colors, right? Makes it a little more bright. Take your time with it. No rush. What am I doing on a, beginning of a weekend here? Doing doodles for you guys. So I want you to get this, okay? So what we remember then is, according to the chemical formula above, we got to follow that little recipe. So it's 2 Cus for every sulfur. And I'll just color those guys in there. It's like I'm doing a little drawing, little Bob Ross over here. I don't have the afro though, just the nice soothing voice. Okay, check it out. Okay, so I get 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Oh my goodness. Okay. So I got to draw 16 of these guys. That's all right. You're worth it. You know I love you. You know I'll take that time out for you. No problem. 1, 2, 3, 4, 5, 6, 7, 8. 8 circles. Okay, times 2. Okay, keep going. 9, 10, 11, 12, 13, 14, 15, 16. So this S8 thing has got me really curious. Like, what is this? Like, explain that, right? So where could we go to find that out? Well, obviously, we can go to Dr. AI there, Dr. Copilot, and say, explain S8, elemental sulfur, octa-atomic sulfur. Explain that, include academic sources, whatever, okay? Now, we know that sulfide, check this out. This is all going to work out because this is actually called copper 1 sulfide. Reason I know this, okay, is because sulfide has a charge of -2. And this is an ionic compound. So every sulfide is a -2, which then, by definition, means that every single one of these guys has to have just a 1+ charge. And I don't have to even write the number 1. Check it out. So we can say 16 atoms of copper react with 1 molecule of, I don't know, octasulfur or just sulfur, I guess. Yeah, just sulfur. Because if we're going to call O2 oxygen, we don't say dioxygen, we say oxygen. So react with 1 sulfur in its octa form. I don't know if sulfur only comes that way. Maybe that's all it does. I don't know. Okay. But what we do know is we've got 16 of these dudes. We got 1 of those, and that's going to give us 8 units of copper 1 sulfide. And there we go. So here we have again. Look at that. A plus B. So an element plus an element gives us a compound. So there's your synthesis reaction. Again, what's it say? 2 or more reactants combine to produce a new product. The part means there's only 1. Okay, and it says, how can you be sure you've balanced the chemical equation correctly? Well, we just did. We used one of the methods to prove our work, right? We're using, in this case, I like the cloning method. That's just my preference, right? We could have used the, what's it called? Ghosting method or accountant method, right? I don't want to do math. I like counting cute little colored circles, right? And that goes for even when I'm teaching grade 12. This is how I'll draw it out, or grade 11, I'll draw it out like this. Because then it's matter, it's real chemistry, it's not just math history, okay? So there's the solutions to these things, and if you want to do it the accountant way and that works for you, that's cool, all right? I like this particle way because it gets my brain to think, hey, there's actually something there, and it gets me to consider what every substance is actually made of. Okay, and I've put a little bit extra in there for you so that you understand, and I hope this video helps.